Functional group. In organic chemistry, we come across many compounds which belongs to different class of organic compounds. How do we classify these organic compounds? The organic compounds are classified based on the functional group that they possess. Now, what do you mean by a functional group? Functional group is defined as an atom or group of atoms that are joined in a specific manner and which determine the properties of an organic compound. So, clearly it is mentioned that the properties of any organic compound is determined by a functional group. That is, the properties of organic compound are dependent on the functional groups, and functional groups are nothing but atoms or group of atoms which are joined in a specific manner. We'll just take few examples. Alcohols, they have a functional group OH. In the same way, aldehydes have a functional group CHO, and ketones have a functional group C double bond O. Homologous series. Homologous series is defined as a series of closely related organic compounds which can be represented by a general formula, and the members of these series are called homologues. And coming to the general characteristic properties of homologous series, first thing, all the members of the series can be represented by a general formula, or all the members of the series have the same functional group. That is, they belong to the same class of organic compounds. Second one, two consecutive members of the homologous series differ in their formula by a methylene group. That is, two consecutive members of the same series differ by a methylene group. That is, they differ by one carbon atom and two hydrogen atoms. They can be prepared by similar methods. Since they belong to the same class of organic compounds, they can be prepared by similar methods, and they exhibit similar chemical properties. That is, the compounds which belong to the same homologous series will have same chemical properties. Next thing, their physical properties like melting point, boiling point, etc. show a regular gradation with the increase in molecular masses. That is, as molecular mass increases, the physical properties like melting point, boiling point, density also increases. There are many homologous series of organic compounds. To name a few: alkanes, alkenes, alkynes, aldehydes, alcohols, etc. Nomenclature of organic compounds. There are two systems to name an organic compound. First one, common or trivial system, and the second one, IUPAC system. In common or trivial system, the name of the organic compound was derived from the source from which they were obtained. For example, the acid that was found in citrus fruits was called citric acid. The acid that were present in red ants were called formic acid because the Latin name of red ants is formica. While the IUPAC system, or the International Union of Pure and Applied Chemistry, the name of the organic compound is derived from the parent hydrocarbon and the functional group which it contains, and the IUPAC name consists of three parts. First one, root word, second one, suffix, and the third one is prefix. The first part of the IUPAC name of the organic compound is the root word. What do you mean by root word, or how do you define a root word? Root word indicates the number of carbon atoms present in the parent chain of the organic compound. So, root word indicates the number of carbon atoms that is present in the parent chain. Now, we have come across a new term, parent chain. What do you mean by a parent chain? Parent chain is nothing but the longest possible carbon chain of the organic compound. It is the longest possible carbon chain of the organic compound, and this longest possible carbon chain may be a straight chain or it may be branched. How do we identify the parent chain? There are certain set of rules to identify the parent chain. What are the conditions to select the longest chain or the parent chain? To select the parent chain, we have a rule known as the longest chain rule. It states that the chain should contain maximum number of carbon atoms. And as I have told you, the parent chain may be a straight chain or it may be branched, but it should contain maximum number of carbon atoms. And the chain should include double bonds, triple bonds, or the carbon atom having the functional group, even if it does not contain maximum number of carbon atoms. And depending upon the number of carbon atoms present in the parent chain, we assign the root word. The root word is assigned, or the root word is given depending upon the number of carbon atoms present in the parent chain. That is, we have a table here, number of carbon atoms and the root word. If the number of carbon atom is 1, the root word is meet. 2, eth. 3, pro. 4, but. 5, pent. 6, hex. 7, hept. 8, oct. 9, non. 10, dec. Now let us consider certain examples to identify the parent chain. I have written a compound, and this compound there may be 3 possible carbon chains, which I have indicated by the arrow marks. This is one carbon chain, and now let us count the number of carbon atoms present in that carbon chain. It is 1, 2, 3, 4, 5, 6. That is, this carbon chain contains 6 carbon atoms. Now you have the second chain of carbon atoms, 1, 2, 3, 4, 5, 6, and even this chain of carbon atoms contain 6 carbon atoms. Now we have another chain of carbon atoms. Let us count the number of carbon atoms in this chain. It is 1, 2, 3, 4, 5, 6, 7. That is, there are 7 carbon atoms in this chain. So you can clearly say that this will be the parent chain, and since there are 7 carbon atoms in this parent chain, the root word of this compound will be hept. Now we will try to identify the parent chain in this compound. I have indicated 3 carbon chains in this compound. First one, it contains 1, 2, 3, 4 carbon atoms. This chain contains 1, 2, 3, 4, 5, 6 carbon atoms, and this chain contains 1, 2, 3, 4, 5 carbon atoms. Now, according to you, which will be the parent chain? The longest chain rule says that the parent chain should contain largest number of carbon atoms. According to that rule, this should be the parent chain, but strictly speaking, this will not be the parent chain. Instead, this will be our parent chain, because the second law states that the parent chain should contain double bonds, triple bonds or the functional groups. Since COOH is the functional group here, the COOH group should be included in the parent chain, even though the parent chain do not contain the largest number of carbon atoms. Even though this chain contains 6 carbon atoms, the functional group will not be included in the chain. Therefore, even though this chain does not contain maximum number of carbon atoms, since it contains the functional group, this will be our parent chain, and this parent chain contains 5 carbon atoms. Therefore, the root word will be pent. After selecting the parent chain, the next step is to number the parent chain either from the left hand side or from the right hand side by following certain set of rules. And these set of rules are known as the lowest number rule. The lowest number rule states that if the parent chain contains one double bond or one triple bond or one functional group or a substituent group, then the parent chain is numbered in such a way that the carbon atom of the double bond or the triple bond or the functional group or the substituent should always get the minimum number. That is, you are supposed to look into the parent chain. You are supposed to look for any double bonds or triple bonds or functional groups or substituents, and then you are supposed to start numbering the parent chain in such a way that the carbon carrying the functional group or the substituent or the double bond or the triple bond should get the least number. We will consider certain example to know how to number the parent chain. Here, the parent chain contains 5 carbon atoms and we have numbered it from the left hand side as well as from the right hand side. And if we observe here, the parent chain contains a double bond. According to the lowest sum rule, the double bond should get the least number. So, if I number it from the left hand side, 1, 2, 3, 4, 5, the double bond lies between the 4th and 5th carbon atoms. And if I number it from the right hand side, the double bond lies between 1st and 2nd carbon atom. So, this way of numbering is wrong and this way of numbering is right. That is, in this case, the numbering is done from the right hand side. And remember, if the parent chain contains a double bond or a triple bond, then the double bond or the triple bond will always belong to the previous carbon atom. That is, in this compound, there is a double bond between the first carbon atom and the second carbon atom. And this double bond will belong to the first carbon atom, that is the previous carbon atom. If a double bond lies between 4th and 5th carbon atom, then the double bond belongs to the 4th carbon atom. Remember, the double bond or triple bond in the parent chain will always belong to the previous carbon atom. And you are supposed to know another term known as locant. What do you mean by locant? Locant is nothing but the number of the carbon atom to which the double bond or the triple bond or the functional group or the substituent belongs. Here the locant is 1, that is the double bond belongs to the first carbon atom, therefore the locant is 1. It indicates the number of the carbon atom to which the double bond or the triple bond or the functional group or the substituent is present. Now we will take another example. Here I have numbered from the left hand side and I have even numbered from the right hand side. Which way of numbering is right? In this example, the functional group is COOH, that is carboxylic acid. According to the lowest sum rule, the functional group should get the least number. If I number from the left hand side, the functional group get a number 1. If I number from the right hand side, the functional group gets the number 3. Therefore, the right way of numbering is from the left hand side, and in this case the locant is 1. Coming to this example, I have numbered from the left hand side and even from the right hand side. If I number it from the left hand side, the second carbon atom carry the functional group. The second carbon atom carry the substituent CH3. If I number it from the right hand side, the substituent will be present on the fourth carbon atom. According to the lowest sum rule, the right way of numbering this organic compound is from the left hand side, and the locant in this case is 2. Coming to this example, the functional group here is OH, and this is the carbon carrying the functional group. Now, if I number it from the left hand side or from the right hand side, the locant will be 2 itself. That is, the carbon carrying the functional group will get the number 2. Either I number it from the left hand side or from the right hand side. So in this case, both ways of numbering is correct. That is, you may number it from the left hand side or you may number it from the right hand side. Both ways are correct. If the parent chain contains more than one double bond or more than one triple bond or more than one functional group or more than one substituent group, then the parent chain is numbered according to lowest sum rule. If the parent chain contains only one double bond or triple bond or functional group or substituent groups, then it is numbered according to lowest number rule. If it contains more than one double bond or triple bond or functional group or substituent group, then you are supposed to follow the lowest sum rule. Lowest sum rule states that if the parent chain contains more than one double bond or triple bond or functional group or substituent group, then it is numbered in such a way that the sum of the locants assigned to the double bond or triple bond or functional group or substituent group should be minimum. We all know that locant is nothing but the number given to the carbon atom containing the double bond or triple bond or functional group or substituent groups. If there are more than one double bond or triple bond or functional group or substituent group, then the sum of the locants should be minimum. Let us consider certain example to understand the lowest sum rule. We will take this example where the parent chain contains 6 carbon atoms and While numbering this, I can number either from the left hand side or from the right hand side. There are two possible ways of numbering this compound. But which is the correct way of numbering? If I look into the locants while numbering from the left hand side, the locants are 2 and 4 and the sum of which gives 6. If I number it from the right hand side, the locants are 3 and 5, the sum of which gives 8. Lowest sum rule states that the sum of the locants should be minimum. Therefore, this will be the right way of numbering the parent chain. That is, the parent chain should be numbered from the left hand side. Coming to the second example, the locants are 2, 3 and 4 if I number it from the left hand side, and the sum of the locants is 9. If I number it from the right hand side, the locants are 1, 2 and 3 and the sum of the locants is 6. According to lowest sum rule, the correct way of numbering is from the right hand side because the sum of the locants gives minimum number. That is, in this case, the parent chain is numbered from the right hand side. Coming to the next example, the parent chain contains a double bond and a triple bond, and if I number it from the left hand side, the locants are 1 and 3. That is, if there is a double bond or a triple bond, the double bond or triple bond belongs to the previous carbon atom that we have studied. Therefore, the locants are 1 and 3, the sum of which gives 4. And if I number it from the right hand side, the locants are 1 and 3, the sum of which again gives 4. So, which is the right way of numbering? In such cases, you are supposed to follow certain rule which says that if same compound contain a double bond, triple bond, functional group and a substituent groups, then the parent chain is numbered by giving following order of preference. That is, functional group is given the first preference, followed by the double bond, followed by a triple bond, followed by the substituent groups. In this case, the parent chain is numbered in such a way that the double bond should get the minimum locant, and in this case, if I number it from the left hand side, double bond gets a locant 3. If I number it from the right hand side, double bond gets a locant 1. Therefore, the correct way of numbering is from the right hand side.